Today we're doing some examples on continuity and one-sided limits. Example 1, I have x plus 2 over x squared minus 3x minus 10. The first thing I'm going to do is factor. Always factor. Get comfortable with factoring. Okay. X, factors of 10 are 2 and 5. I need a negative 3. Oh, these guys cross out. So what's that mean? I have a whole. Okay. Is it continuous? No, it has a whole, and what else? Because this simplifies, remember, there's a 1 on top. All right, so there's a whole at x equals negative 2, and there's an asymptote at x equals 5. Are they removable or non-removable? The asymptote, such a good word, is non-removable. X equals negative 2 is removable by defining x equals negative 2 to be 1 over negative 7. Okay? All right, number 2, show that f of x is continuous at x equals 2. Well, this is a piecewise function. You've got a parabola when x is less than 2, and you've got a line when it's greater than 2. What happens is you need to know, as if it comes in from the left and right, do you end up at the same point? Well, I plug 2 in here, you get 2 squared, and you want to know, is it equal to 6 minus 2? So you got 4 equals 4. Yep, it's continuous, because that's the point. That's the break in your piecewise function. All right. Number 3, does the data in the table support the statement that between 5 and 10, your speed was 27 miles per hour at some point? Well, first, this is continuous. Continuous. So, IVT applies. And since 25 is less than 27, which is less than 30, therefore, t, how do I want to say that? Therefore, there is a time, t, between 5 minutes and 10 minutes when my speed was 27 miles per hour. Usually, don't forget units. Use units. Show your work. Write sentences. Okay? All right. Now, last examples. It says find the value of the constant k, if possible, that will make the function continuous for all values of x. So what you're worried about is the point where there's a break. You got a piecewise function. This is coming in from the left. This one's coming in from the right. You want them equal. So you plug in 1. So you got 7 minus 2 equals k times 1 squared. So you get 5 equals k. Oh, we're done. So if k was 5, you're going to have a continuous function. All right, this one you plug in 2 for x, and you get 4k. It's equal to 4 plus k. The mistake made on these is plugging 2 into k instead of x. So plug it into the x. Subtract k, you get 3k equals 4. So k is equal to 4/3. Boom. All right, the last one is find the values of the constants k and m, if possible, that will make this function continuous everywhere. I don't like the fact that this is upside down. We got our small numbers, then our big numbers, but we will work with it. Okay, so there's 2 breaks. You got to break at 2, and you got to break at -1. So first I plug 2 into that equation. You get 2 squared is 4 plus 5 is equal to, then I have to plug 2 into this one. 2 plus 1 is 3, so I get 3m plus k. So that's 9 equals 3m plus k. now plug -1 into both equations. Well, -1 plus 1 is 0, so I end up with k equals -1 in here is what? -2 minus 1 plus 7. So I think that's 4. So k is equal to 4. Plug it back in here. Plus 4, subtract it, and you get 5 equals 3m. So m is equal to 5 divided by 3. And you've solved the problem. Easy peasy.